Hello everyone and welcome back to my YouTube channel. Today I'm going to look at trigonometric identities, and trigonometric identities are very important because they help you solve trigonometric equations. Now I'm going to start with the most commonly known. I'm sure you've come across the word SOHCAHTOA. Now SOHCAHTOA, if you have a triangle, a right angle triangle, and you have an angle theta here, then sine of theta, of this angle theta, is given by opposite divided by the hypotenuse. Alright, then the reciprocal of sine is known as cosecant, written in short form as CSE. So cosecant of theta is the same as 1 over sine theta. Also, if you have cos theta is given by adjacent A divided by the hypotenuse. The reciprocal of that is known as this secant, or simply sec, and is given by 1 over cos theta. Finally, you have tangent. Tan theta is given by opposite all over adjacent. Opposite over adjacent. The reciprocal of tan is cotangent, or simply cot. Therefore, cot of theta is 1 over tan theta. Also, sin theta over cos theta is also given as tan theta. Therefore, it follows then that cot theta is the reciprocal of this, that is cos theta over sin theta. The next one is called the Pythagorean identities, and you have sin squared theta plus cos squared theta is equals to 1. Therefore, cos squared theta is equals to 1 minus sin squared theta, and sin squared theta is equal to 1 minus cos squared theta. Now, if you are to divide here by sin squared theta, you will get 1. If you divide here by sin squared theta, you will get cot squared theta. And 1 over sin squared theta is cosecant squared theta. Similarly, if you have to divide this equation throughout by cos squared theta, you get here sin squared theta divided by cos squared theta, which is the same as tan squared theta. This one will be 1, cos squared theta divided by cos squared theta will be 1. And this one will be 1 over cos squared theta, which is the same as sec squared theta. So these are the other, you can easily derive this. If you remember this one, all the others, you can easily derive them. The next one I'm going to, to look, it's called the cofunction identities. And that one, if you have cos squared theta, the two angles add up to 90, then sin theta is given as 90 minus theta. And it's true, you can even prove with your calculator that cos 30 is the same as sin 60. Then it follows for all the other identities. Okay. Now the last one, but not least, if you have, it's called a double identity. Sin 2 theta is given by 2 times sin theta multiplied by cos theta. Again, cos 2 theta is the same as cos squared theta minus sin squared theta, which is the same as 2 cos squared theta minus 1, which is also the same as 1 minus 2 sin squared theta. You can try and prove this. Last but not least, tan 2 theta is the same as 2 tan theta all over 1 minus tan squared theta. Thank you for watching. Remember to like my video and also to subscribe if you haven't. Now in the next video, I'm going to use these identities to solve this equation here. It says prove that cos 2 theta over cos theta minus 1 plus tan squared theta over sec theta is equals to minus 2 tan theta sin multiplied by sin theta. Thank you for watching and remember to subscribe.